All right, pause your videos and see if you can complete this formal proof. So you've got one premise and you're aiming for that conclusion. So pause your videos and try to work this out now. Okay, that was your chance to pause your videos. If you didn't know how to start this proof, then you don't yet know how to reason from an existential sentence. So we have an existential premise and an existential conclusion. And this is the important thing to know about existentials. An existential conclusion does not automatically tell you how to solve the proof. If you have a universal conclusion, that does tell you how to solve the proof because you just box a constant and you roll with it from there. But an existential conclusion is not like that. On the other hand, an existential premise is wonderful. That tells you exactly what to do. Because if I know that something in my domain has property P and R, then I just need a way of talking about that thing. And again, what we use is the convention of boxing a constant. So this is the last rule you need for quantifiers, and it's the other annoying rule because it requires a subproof, and it also requires this new device of boxing a constant. So given that the name A does not appear anywhere else in my proof, I'm going to use A. If the name A appeared in my premises, of course, then I would just box B or whatever the next letter is in the alphabet. Now, unlike universal intro proof, remember when we boxed a constant previously, we didn't put anything over here because we wanted A to be totally arbitrary. But existential EElim is different. I don't want to talk about a totally arbitrary object in my domain. I want to talk about some object that has property P and R because I'm talking about this thing that I know exists. So an existential premise requires me to write a formula next to the boxed constant, and you leave exactly one space here. So I just insert the name A everywhere, whatever that this variable appears. So namely with the P and with the R. And what do I need to prove? Well, in this case, you prove any sentence you want down here and you export it. So in that sense, it's a bit like proof by cases, just with one case. The sentence that you prove down here, though, must lack the name A. That's the important restriction. Because remember, in order for A to be arbitrary, we still keep the convention that A is not allowed to appear outside the subproof. And indeed, if this sentence had A and got exported, then A would appear outside the subproof. So you first have to eradicate the name A from this. Now, what would I want down there? Well, of course, look at my main conclusion. It lacks the name A. I want this sentence down there, and then I'm going to export that thing. That's how the majority of existential EElim proofs work. Okay, so if you didn't know how to start the proof this way, now pause your videos and see if you can finish off the proof before we continue. Okay, now we shall continue. I just look at my main connectives, and now I see that I have a wide scope conjunction, so I'm just going to bring down the conjuncts. Well, I guess I only need one of the conjuncts, because then I'm going to look at my conclusion and realize, look, I need to know a P, but I don't even need the R. I'm going to just add Q with disjunction intro. So now I've got this sentence. But don't stop here because this has the name A in it. What we need to do next is existentially generalize. It would have been a mistake to first put the existential generalization here because then the existential would have been narrower scope than the disjunction. So look at the structure of this thing. Whatever is inside the scope of my existential, I need to build that up first before I do existential intro because existential intro always sticks that quantifier wide scope. Now, this lacks the name A, and I can just export it. And here's how we justify it, existential EElim. And you always have to cite the existential sentence you're eliminating. You can't do this if you don't have an existential premise somewhere or an existential sentence that you know. And then you just cite the subproof. So that's why we did 2-5. Okay, now if you're wondering where we stand then, what are we doing here? We're doing the final part of first order logic, FOL. You've learned the formal language, you've learned the semantics. Now we're doing the proof theory for the quantifiers. And indeed, you've already learned all of the rules. You've learned universal intro, universal EElim, existential intro. We're finally completing existential EElim, and you will have all of your quantifier rules. In another video, we'll give you the identity rules. Those are pretty straightforward and not too difficult. And then you'll have the complete system of first order logic. Now, in case you like to see these schemas, you've already learned these 3 rules in red. Here is the schema, the abstract pattern for this existential EElim rule, how it works. So all the EElim rules work only if you have some operator that's the main connective. So I need some existential sentence, like a premise or other. Like, let's say it's EXPX. Now, in order to do this rule, I have to start a new subproof and box a new constant, so A can't appear anywhere outside of this thing. And I need to write a formula next to my boxed constant now, because I don't want to talk about a totally arbitrary object. I want to talk about some arbitrary object that has property P. So that's why I assume A has property P. And the sentence, notice S, this sentence must lack the name A. And then I just get to export that thing out here, and I cite 2 things. I cite my existential sentence, and then I cite the subproof in which I box the constant. Okay, thanks.